Welcome. I am Professor Manoj Franklin, and I'm going to teach ENPM615 Embedded Systems. In the past, in your computer engineering education, the computing systems that you would have seen more often would be laptops, desktops, that kind of systems. But there are another type of computers that are far more in common than these general purpose systems. And what are they? They are embedded systems. In fact, embedded systems are there everywhere. But they are hard to define. What exactly is an embedded system? Well, if I go through some examples, you'll get the idea. Here we have a bunch of examples. We have a car, automobile, a digital camera, a washing machine, etc. And all of these have a lot of embedded systems inside those. A huge list is given here, and so they are everywhere. Pretty much any system you take today, microwave oven, yes, it has embedded systems. If you look at a digital camera like a digital SLR camera, that has many embedded systems inside that. So what is an embedded system? An embedded system is one where the primary focus is not computing. Yes, it is doing computing, but it's not the main focus. The main focus is interacting with the environment, getting inputs from sensors, and then making some controlled decisions and making some actuators move, things like that. So robotics, you name it. I mean, there are so many applications for embedded systems. If you look at a modern automobile, it has hundreds of embedded systems for engine control, for brake, ABS, seatbelt wearing, everything. I mean, it's just all over the place. So what are the characteristics of embedded applications? Unlike general purpose systems, embedded systems are more application specific. And they are tightly coupled with the physical environment in which they are operating. They are reactive in the sense they need to react to what's happening in the environment, particularly inputs from sensors, etc. And many of the embedded applications have deadlines. For instance, if you are considering the ABS system in a car, it needs to provide the output in a timely manner, otherwise there could be a crash, and the result would be bad. So another thing is there are tight constraints when designing an embedded system. Unlike a general purpose system, most of these are operating from a battery, so you need to conserve energy, but you need good performance, and you need it to be small, like a digital camera or an Internet of Things sensor. They need to be very small and cost efficient. So the constraints are many, and we have to design the hardware and software together. We call that as hardware-software co-design. This is, again, different from what you may have seen so far in general-purpose computers. So there are a lot of challenges in designing an embedded system. We have to make sure the specification is correct, things like that. And most importantly, we have to optimize a bunch of design metrics, which unfortunately are sometimes contradictory to each other. For instance, you want the cost to be low, but then you want good performance, you want good reliability, and unlike some other systems, you need to also consider how much time it will take to design this product, because most of these are used by consumers, and before you know it, another competitor would have made a better design, and that's now appearing in the market. So things like that we need to be aware of. So I would say designing an embedded system is quite challenging, and that's what we will try to talk about in this course. We'll do some designs. And so the objectives of this course are you should be able to define what an embedded system is. You need to identify where it is used, and you need to understand basic microprocessor functioning, etc. Then you should be able to do design analysis. We'll be using an ARM-based board to do some designs, and you would be also doing a project, an embedded systems project with the ARM board. Then write that in a report, make a presentation, things like that. So that's the overall objective in this course. And in conclusion, embedded systems are everywhere, and designing one requires you to design both the hardware and the software together. Then it is challenging because there are more constraints to building an embedded system compared to building a general purpose system. And that's what we are going to learn in this course. And then in the following courses like embedded system hardware, we'll focus more on hardware. Then embedded system software, we'll focus more on software, etc. Thank you.